Hello again. We're back with more adventures in automation, and this week I plan on getting my hands dirty. Having got to a point where we know which actions we want to build into our automation project, we now need to look at how we gather all the information to allow us to execute on it. IP Fabric has collected and analysed all this data for us, so now we need to get our grubby mitts on it to feed it into our automation tools. We're not going to launch into a long discussion about tooling. We'll be using the de facto standards of Python and Ansible initially. The way we get that data into those tools is through the API, the Application Programming Interface. Put simply, the API is a method and set of commands to allow two pieces of IT infrastructure to interact in a standardized way. It's a way of System A allowing System B to issue commands to be executed on A, then retrieving and manipulating A's data for its own processing. Now that's useful to us because, as we know, IP Fabric's discovery engine has connected to all of our network devices, retrieved a load of data which has then been analysed and validated and stored in our database. That data is incredibly useful to us as we want to check all the inventory for certain configuration and state. So our external system can use the API to retrieve that data from the database, to update certain information about the network, and also to trigger certain operations in the system, like creating new validation checks or starting new snapshots. Our API is considered a RESTful API, accessed over the HTTPS protocol, which allows us, after authentication, to ensure all data and commands are encrypted in transit between the systems. REST, or Representational State Transfer, bit of a mouthful, is a standards-based approach which uses a set of key HTTPS methods to transfer data between systems. In our case, the main three methods are POST, which is used to trigger actions in IP Fabric and pass results back to the external system; GET, which is used to retrieve data, fairly obvious; and PUT, which allows us to write data back to the platform, such as IP Fabric configuration itself. In this video, we're going to be looking at just how we build those API calls and test them, ready to use them in our scripts. To do that testing, we're going to use an open source tool called Postman, which was actually created to help developers build better APIs. It allows us to craft calls to any platform supporting RESTful APIs and see immediately the responses and valid formats. When we're happy with the calls in question, Postman will generate code to replicate that API call in a range of programming languages, including Python, our choice, and that of many a network engineer. Postman allows you to define environments, sets of environment variables, to represent data specific to the platform you're testing. In our case, my IP Fabric lab has a particular IP address and base URL. I've got the credentials in here, and I've got space for the authentication tokens created during the login to the platform. You can then create collections of API requests for reuse, so you're not having to recraft those calls, and so you can test them with different parameters and settings. In my case here, you can see I've got a number of collections, including this one for IP Fabric, which is available for you to clone from my GitHub repo. The details will be on the screen and in the notes. What we're going to do now is open up the GUI, take a look at some of the data we can get from the web UI, and then take a look at that API and see how the same data is accessible programmatically. Before I start, it's worth noting that if you want more detail about how to access IP Fabric through the API, we have a series of recorded webinars on the YouTube channel which delve into it in more detail. The links for those are in the notes. Okay, first things first. In order to get anything out at all, we need to log in. In the web UI, this is a simple case of hitting the login dialog with a username and a password to be presented with the verification check dashboard. If you do nothing in the web UI now, your session just times out and then you'll need to re-authenticate. In the API, it's the same. IP Fabric uses RFC 7519 JSON web tokens to provide access to the environment using the same credentials from the web UI. You can see here in Postman how the request is assembled. We've got up at the top here, we've got the method, post, get, put, and so on. You can choose any of these. HTTPS because we're using HTTPS, but the host IP and the URL, if you hover over them, you get the detail of what they contain. But these are again pulled from the environment variables defined over here from this list. The body of the request can contain JSON or whatever, in our case it is a JSON request with the username and password, and that again takes that information from the environment variables. When we click on send, the request goes away, comes back as an OK, and then these values are returned. Those values will get written back into environment variables. So again, if we come back into the OPF lab, we can see the token and refresh variables here and the values that are added into there. The access token lasts 30 minutes. And if it expires, what we can do is use the refresh token to generate a new access token as part of the same session, so we can just re-authenticate. You can see that in the refresh request here to a slightly different URL, and in the body we just pass the refresh token, which again is pulled from the environment variable, and if we click send, it simply returns an access token, and we can reuse that refresh token in the next half an hour when this one expires. So once we've been authenticated, we're able to pull any of the data in the platform. For example, we often talk about the power of the automated discovery to create an up-to-date inventory. In the web UI, we can bring up the device table to give us a list of the devices in the network, like so. In our case, if we scroll to the bottom, we can see that we've found 520 items in total across the lab environment. Now, the table here, you'll notice we've got some interesting options in the header. For example, we can change the view by adding or removing columns. We can export that data to a CSV, so enabling us to use that data elsewhere, so pulling it into a spreadsheet, for example. Or, and in this case is the one we're really interested in, if we hit this rather cryptic table description, what that actually gives us is the API information that will enable us to pull that same data. You can see the URL there, the method that you need to access it, and underneath here you can see a whole load of information about the variables and that are included in the payload. And then at the top, this request payload is the very API call itself that would generate the current contents of that inventory table. Now, we can get clever now, because we can take that information and put it straight into Postman to build an API request. So if I go to my inventory folder here and choose device list, you can see we go to tables inventory devices, which was the URL from the table description. And in the body, this is an exact replica, give or take, of what was in the request payload from the web UI. Now, there's some very subtle differences. I've reduced the number of columns because I'm not interested in some of them. And I use a special snapshot filter, the $last, which refers to the latest loaded snapshot. But otherwise, the form is exactly the same, with the URL and the method matching too. Clicking send fetches the data, which should match with the data that we saw in the web UI. And if we scroll to the bottom, we can see a count of 520, which matches what we saw before. So it contains all the information that we specified in that column list for all of those devices. Again, if we scroll this up, you can see serial number, host name, site name, login IP, the way we logged in, uptime, and so on. So plenty of useful information there. Now, if I come back to the web UI and I choose to, let's say, filter to get site 1, which is from our problem statement, the site we were interested in for our NTP, we can see that we're now only pulling 27 items. If again we come back to the table description, there's a change, and that change is here in the filters line. You can see that we've got a filter set on site name to be like L1. And so if I come back to Postman, come to filter the device list by site, you can see here that again I can just take that exact same information, place it into the filter line in Postman, hit send, and I will get from the count here 27 devices, the same 27 that we saw in the web UI. Now, you'll recall from our problem statement we're interested in the Site 1 device's NTP configuration and state. Let's see if we can find the data we're looking for in the web UI. If we search for NTP and click through the sources, we reveal a table of all the places where NTP servers have been configured in the network and what their status is. You can see here where things have been connected, and we can see the jitter and poll times and so on. If we filter this by site 1, we now have a list of, let's have a look, 20 items. We can sort the host name ascending, and we can see exactly where multiple sources have been configured on devices. And it looks like from this that that's only happened in one case. L1FW1 here has 2 sources configured, 1.1.1.1 and 10.0.10.10. 1.1.1.1 isn't reachable, but the 10.0.10.10 is. And you can, as a result of 1.1.1 not being reachable, the stratum is at 16, and we don't have any information here about its actual NTP state, whereas 10.0.10.10 is stratum 2, and we have a delay, offset, and so on. So we know that it's synced and configured. Again, clicking on that question mark gives us the request information and the payload details, and this we can transfer into Postman. So if we go into my collection and to NTP sources, you can see we're now heading for tables management NTP sources. So post again, and in the body what we're looking for are these columns. Again, all the detail about the state of NTP. We're looking for filtered by site name, looking for L1. We're looking at the last snapshot, and we've got a new item here. Is the sorting order for the column host name. So if we hit set on this guy, we can see the same information. There are the sources, and there are the, in fact, if we scroll back up, you can see the two sources. That one's the 1.1.1.1 for L1 FW1, and this is the 10.0.10.10 for L1 FW1. Same information. Again, scroll to the bottom, you can see the count is 20. And so that output matches. And of course, once we've got it in that form, we can programmatically do something with it. Now, Postman's got a nice little feature for that, and one that I haven't shown you yet. But if you click through on this code button over the right hand side here, what it can give you is code snippets for executing that API call in all of these different languages. And you can see here the one we've got currently selected is Python, using the requests module. If you see here, if you import the request module and set the URL with this payload, you set the headers obviously to the authentication token, so you wouldn't necessarily put that straight in here, but just as an example, execute a request, put it into the response will return that data, and so you're able to then manipulate it programmatically. So it just shows you how you pull that data in directly into a Python script. So that sets us on the path. To wrap things up for today, I wanted to show how we can get IP Fabric to look after some of our more complex logic for us in our example. In the platform, we've got the ability to perform what we call intent verification checks. We define rules on how we want the state and the config to look, and the system runs those checks and reports on them each time a snapshot is created. Our example scenario was to check all Site 1 devices for NTP sources. They should be configured for 10.0.10.10 and 10.0.10.15, and both should be reachable. If we look at the web UI, we can build a verification check that does exactly that for us. So, from the dashboard, we search for NTP, and we head for the NTP summary, and we have all the information here that we need to carry out those checks. In fact, you can see here we've already built an intent verification rule. If I click through on this, I can show you what that looks like. Essentially, what we're going to do here, we're going to colorize the column host name, and we're going to color it green if the site contains L1, that we've got two configured sources. Those two configured sources include 10.0.10.10 and 10.0.10.15, and that both of those sources are reachable. Select blue where it's configured correctly but the state's not good. Same conditions, except we've got a reduced number of reachable sources. We're going to colour it amber if it's configured incorrectly, where the site still contains L1 and our configured sources are greater than 0, so we have some configuration, but that our sources don't contain 10.0.10.10 or they don't contain 10.0.10.15, so we need to make sure that both of those are right. And then we're going to colour it red if there's no configuration at all. Now, at the moment you can't see the result of that, but if we click through on the colours in the table up here, it shows us instantly. These are the 9 devices that are in Site 1 with no configured sources, and these are the 18 where in Site 1 where either the number of configured sources is wrong or the sources themselves don't match. So we've got a couple here where we've got 2 sources and they're not correct ones. So what we can do at this point is produce a CSV to pass to an engineer to go fix the issue, or we can use the API to build a script around the results of the check and pass it over. Let's look in Postman. Let's just re-authenticate. We can run a list of what are called the reports from the API, which is the intent checks that we've seen before. And once we fetch that list, we can search through that for NTP. And this shows us our intent verification check here. Same data we've seen already. The checks are simple. They're basically given a value, and the value maps to the colours that we've seen in the tables. So in a colour of green is a value of 0, and that shows here that we've got site L1, 2 configured sources, we've got 10.0.10.10, 10.0.10.15, and we've got 2 of those sources are reachable. And that's basically what happens there is we place a value of 0 against the hosts that match that. 10 against ones where the reachable sources are less than 2. 20 against a scenario where 10.0.10.10 or 10.0.10.15 isn't configured, but we do have configuration, and 30 where we have 0 configured sources. So you can see the mappings from the intent verification rules in the web UI to the reports that pull through the API. So now we can take that information and create and check explicitly for the condition we're looking for to pull that data out. And so we've got build this API here. We use the NTP summary table. We do a select of all devices in L1, and then when we retrieve the information there, we can see against the host name we've got the name, and we have what's classed as the severity, and that severity matches the colour that we've talked about from the verification check. So in our case here, L1R9 is going to be amber, as is L1R18, and so on. And then obviously we can pull all of that detail through from one API call into our script, and we have the information here relating to the device, the host name, the site, and so on, so that we can access the device to change configuration. The severity tells us what's wrong with that device. We've got the number of configured sources, we've got the number of reachable sources, and for each source that is configured, we've also got whether or not it's synchronized. So we're able to determine not only how many reachable sources there are, but which ones are reachable, and so which ones we need to troubleshoot. Anyway, we've made some big strides today, so we're going to pause there before we crack on with looking at getting those API calls into scripts where we can use and manipulate the data. I hope you've learned something today. I've learned loads. Feel free to clone my IP Fabric GitHub repo to get a copy of those Postman collections and any other materials from the series as we progress. And don't forget, please, like and comment on the video, subscribe to the channel for future episodes, and hit that notification bell to remind you when we release them. And continue the conversation on the Network to Code Slack, or drop me an email with your thoughts. Look forward to seeing you soon for more adventures in automation.